So now we have technically reached a point where we actually have a complete game with a start and an ending. You can go around, you can keep picking up these boxes, you can drop them off in the drop-off area. You can keep doing that to get yourself more time, and eventually you'll run out of time, at which point the game will notify you that you have lost. You'll get the game over screen, and you can choose to either try again, and it will restart at the set parameters from before, or you can just choose to quit and be done with the game. So now is the time when we have the opportunity of keep building layers upon this. So this is where you can start to get creative with your systems. You have something basic core that works around some idea that you have, and now you can add upon them. So let's start adding some things to this to increase the complexity, give the player more things to do, and make the game experience more challenging. Let us start off by cleaning a little bit with the things we have done so far, so it looks a little bit better. We can maybe move the conveyor belt up a little bit, turn it around so it's facing the direction of the drop-off area. Let's go to the game state. Let's set our time remaining to 100, which is the max time, so that we don't get a game over screen all the time. Let us move the drop-off area a little bit. Let us scale the conveyor belt a little bit so we get a higher volume. And let's see how this looks. Okay, so we're getting some funky physics interactions. That seems like something that could be fun. Like it's piling up and you need to make sure to clean it up before it gets too chaotic, and then drop them off in the area. We're gaining a bunch of time by doing this, so yeah, seems like the systems are like functional at least. So let's start building upon this. Let us expand upon the possible objects that the spawner can create. So currently we only have a box that is being spawned, but we could expand upon this in the way that we have a pickup here. So we could create children of this. So we could do something simple to begin with, so we'll call it BP pickup blue, and we can make another child class. You just right click on the pickup and then choose create child blueprint. That's how we create children. So they will inherit all of the functionality like we have talked about in earlier tutorials. So now we have two children here that we could be using instead, since most of the logic we have built so far is based upon the pickup class. Anything that we would inherit would work fairly easily in the system already. So if we were to go to our spawner, for example, it spawns a BP pickup. But if we instead did something like let's make it random. So we'll random int, nope, let's see here, rand int rand. Okay. What is the function called? Maybe it's because I'm dragging it from the connection. Let's see if we can get it from just right clicking. Yeah, there we go. So by right clicking on this is one of the things that you have to get used to also. We haven't touched upon this, so we'll take a little moment to do that right now. whenever you're doing something like this and dragging off a connection, the things that you're getting as a suggestion when you type something in here, like integer, are context sensitive, which is actually exactly what it says up here in the right. And that means that the engine will try to determine what it thinks you're trying to do. So if you type something called integer, it will present you with all the fields that are reasonable to use with what you're currently doing. So a connection and an integer, then these are your options according to the engine. You can get all the available things that you can do regardless if you click out this context sensitive thing, which means that if we were to type in random and integer now, you can see that our result here that we're after appears. However, for most cases it's very nice to have this checked in, because then you don't get false positives, you don't get suggestions for things that don't work. Like if I was to drag something out from a vector here, I want to have nodes that are relative to vectors, not something that only works on an integer or on a string or something of that nature. So having context sensitivity on is a good thing for most of the time, but sometimes when you know that you're searching for something specific, it can be very good to deselect this checkbox to be able to find it and then rearrange the connectors and the nodes to make it actually work afterwards. So yeah, back to our random. A random integer in this case is a easy node to use when you have a preset number of something and you want to get a random value between them. So for now we have made, for example, two different children classes that we want to spawn. So what we want to do is we want to have a max value, and this goes between, if you hover over it, it'll tell you, let's see where there it says, come on, there, returns a uniformly distributed random number between 0 and max minus 1. So if we were to put in max minus 1, is that correct? I would think that if we have max 1, it would randomize between 0 and 1, and that, so 0 would be one value, 1 would be a different value, so we have two values. Let's try this out actually. Okay, context sensitivity again. Print string, and we want to hook that up, and we want to hook this in. This is just so that whenever this event calls now, instead of spawning, it will instead be typing out the integer converted into a string. So we will see if it will be only getting us 0 values or if we will be getting 1 values as well. This is just to make sure that we're using it properly. So we get a 0, 0, 0. It seems like it is reliable. It is actually doing what it said it was doing. My bad for questioning it. Let's see, where are we? Spawner, yes. So we want to have a 2 here. That means that we will get a result that's 0 or 1, which is what we want, because we want to, in this case, we want to be able to get two different numbers so that we can switch on these. Switch is a way to control game flow, where you can define different outputs or situations. So it takes an input of an integer, and based on the value of that integer, it will go through one of its outputs. So in the case of 0, we can take it into this spawner. In the case of 1, we can take it into this spawner. And when it comes to the location that's supposed to be the same for both of these, we just want to be spawning different items. So instead of pickup, we're gonna take pickup blue, and instead of pickup, we're gonna take pickup red. Okay. So now we need to make a little bit of an adjustment to these classes to make sure that we can make a distinction between them. And an easy way to do that is probably gonna be that we change the material. Let's see if we can find something that is. This is the one that is called blue. Type blue, we get nothing. Okay, I guess we will create some materials then. Just so we have something. So M for material underscore blue. Or let's call this pickup color, and we can at the same time learn a little bit about material instances. So what we need here is a color. So we hold down 3, or we right click and type color to get a color. Where is it even? Isn't it called color? What about vector? Constant 2, constant 3, constant 4 vector. We want a 3 vector, which gives us 3 values. Or you could just hold in 3 key and left click and you'll get it as well. So this will represent our color. We'll plug it into base color. And we will make this one. Let's make this one yellow for now. And I'll show you why. So this is our basic material. It's just gonna look yellow. What we're gonna do is we're gonna right click on the color and convert to parameter and call it pickup color. And then save. So what we've done now is we have made the color of this material sort of like a variable in a blueprint class. Which means that if we right click on our material and choose create material instance, we can call it mi for material instance underscore pickup blue, and you double click on that one, and then we get the material editor again, but it's highly limited because we're in a material instance, because this is like inheritance. It gets the values from its parent, which is the original color that we made, which is also yellow, but we can override the color here and say we want to have a different color, and then we can choose blue. And the reason for doing this is there are a multitude of reasons. One of them is you generally need a bunch of materials when you're creating games for all kinds of different objects and characters and everything like that. But every time you have a material and you want to make a change in it, so if I want to change the color and I add some nodes and everything like that, it needs to compile each time, and it takes a little bit of time. It might not feel like a big deal, but the more complex it is, the more time it takes. However, when you make a change to a material instance, the effect is immediate, and you can also have a color on an object in the world and change it in the material, and you can get real-time feedback about what it looks like, unlike when you change a material where it would take a lot of time between each change, basically. So that's another reason why material instances are really nice. Then we create another material instance from the pickup color, which we call material instance, and then we call this one red. And we go in and we override a color just like before, and we choose a red color we like, and save. Now we go back to our pickup blue, and we click on the material here, type in blue, and now we have a material instance blue. So it's blue and very easily identifiable now. Then we'll do the same thing with the red one. Pick up mesh, click on the material, type in red, pick the material instance red, compile, save. So now that we've made these two different classes, they look different because they have different colors on their materials. Let's try this out and see how it works. Yeah, we're spawning. We should be spawning. So it spawned the red one, it spawned the blue one, it spawned another blue one. This seems to be working fine. Okay, So what is the point of this, you might be asking? Well, now that we've added two colors for our materials, or we're just using colors to differentiate them as different objects. You could be using completely different objects altogether. But now that we have these objects, what we could do is we could also make different drop-off areas. So we could make a drop-off area that only accepts, for example, blue boxes or red boxes. Or it could be that we get a certain amount of time based by if you put the correct box in the correct area. So if this is the blue area, you put a red box there, maybe get half the time rather than the full time if you had put a blue box in. Something like that. So let's make a child of, let's do this, our drop-off area. We can get a text render. We can drag it up a little bit. And it's going to say text, and we want to first of all change the text to, let us say, drop-off area. And we can center its alignment under horizontal alignment so it looks a little bit better at least. And since we're speaking English right now, this should be two different words, unlike Swedish, which is one word. And yeah, let's see how that looks in the world. So this is what it will look like, and that's fine, I think. If we were to make a child now of the drop-off area, we can call this BP drop-off area blue. The naming conventions for these aren't great, and we might have to change some things along the way. And that's also something you might have noticed so far, that we have done something, then we have changed it slightly, then we've done something else, and then we have to go back to something and alter it slightly. The point of this is to also show it is a little bit deliberate, because you don't always write the perfect code solution immediately. Sometimes you write the best that you can from a specific point in time, and then when you add more things you realize that you have a need to expand upon them. And this is a little bit to show you that what we have in the end is not gonna be how it was in the beginning, because we will be adding upon everything and changing upon things as we go along. But this also gives us opportunities to clean up our code as we go along and go back to things and make them better and adjust them and things like that, and add like different ways of communicating, like interfaces and whatever might be, just to always improve upon the game. So now that we have the drop-off area blue, it gets all of the functionality from its parent, which is fine. However, we want to do a few things. We want to, when this is created, we can take the text render, for example, and set text. And let's say we want this one to say drop-off area blue. We could have written it out here as well. That's fine, but this gives us an opportunity to look at some other functionality and learn some other things as well. This is not a string. This is a text. There's a difference. The difference is subtle, but what text allows us to do are a few things. For one, we have the format text node available to us, which is a very nice text, which allows us to say things like, actually, let's do something with inheritance while we're at it. Might as well. So what we're gonna do is we're gonna go back to our drop-off area, and we're gonna make a variable, and we're gonna call this one name. And we're gonna make it a text, why not? So this one is the parent, we will leave that one blank. We will go to, we will continue here a little bit. We're gonna do an event graph. On our begin play here, what we're also gonna do is we're gonna set our text render, the set text for it, and we're gonna do the following. We're gonna set its name from a format text like we spoke about earlier. And this one is gonna be drop off space area space and then these squiggly brackets. Hold on, I need to change my keyboard. There we go, sorry. Squiggly brackets, and then we say name, for example, and then end squirrely brackets. Then you press enter. What this does is it creates a sort of a placeholder, which any word that you place within squiggly brackets like this will be presented as an in parameter for the format of the text. And you can have multiples of these, so you can format like nice text and have it like dynamically change depending on different circumstances. For now, we're gonna be adding name into this area, which means that when this drop-off area, you can start here and you can see, it's gonna be called drop-off area. And the reason it's called drop-off area is we're getting so many things here. I'm gonna close down some materials so I more easily can see things. And let's see, drop-off area, where is it? There. So the name for this one was blank, so it's gonna call it drop-off area and then blank, because it doesn't have a name. This is the base class, the parent. But when we go to the blue drop-off area, we are going to be able to build upon this, because just like the parent has the name, the child also has the name. But you might be reacting, we don't see a variable here, and that is because by default, if you click the eye up here, you'll see that show inherited values or variables are not ticked in, which makes Children Blue classes easier to read because they only have the things that they contribute with. But at the same point, it can be bad when you want to be able to use something from a parent. So we just click this one in and we'll see the variable appear down here. Now you see we get a lot of stuff here, so it becomes a little bit more cluttered, but yeah. So we see the name here, and since this is the blue drop-off area, we will just call this blue. Then we'll compile and save, then we'll go out and try and see what it looks like. So we'll drag in the drop-off area here, and then we'll play. See, drop-off area blue. And yeah, you might notice that it doesn't say drop-off area blue here, and that is because it hasn't run the begin play event yet, because this actually plays when it is constructed in the world when you start playing. If you wanted this to show even when you're dragging it around the world, then you would be having to put, where is the drop-off area? Then we would have put this logic here, which makes the text actually in the construction script instead, because construction script is run while you're moving things around. We might as well show that off since we're doing this anyway. So it will be easier to place things in the world also. So we will mark everything that we want to have here and Control X for cut. Then we'll go to the construction script and we will Control V for paste. And there we go, compile and save. So now that we have both of them in the world here, okay, it's not updating. That is really odd. Let us troubleshoot and see what we can find. So this is our drop area for, let's go to the drop-off area here, the main one, the parent, and we will just print whenever this construction script is run, and we will, okay, this might be it. I apparently neglected to put the name here as well for some reason. Let's assume that this works and go back and check in the world. Okay, so now you see it says drop-off area blue over there and only drop-off area on the parent. So let's continue with making some logic related to which box you drop on the drop-off area. First we'll scale, we'll scale this one up a little bit so it's a little bit easier to see. Move it a little bit, scale it a bit further. That's probably fine. So what we would like to do is to analyze if the box that's being dropped in the area, if it is a class that we want to give full bonus for or interact with in a different way. So what we can do is we go back to our drop-off area and we'll add a variable called desired pickup. So this is supposed to reflect which one we want to be dropped off in this drop-off area. And we'll go and change the variable type for this one to be BP underscore pickup. And then class reference. So we will take this one in as a BP pickup as a default. We haven't used a class reference before, but this allows us to have a specific class in mind when we want to do something. So the desired pickup for the base class, the parent, now is going to be BP pickup. And since I chose BP pickup as the variable type, it will only let me pick among those that are actually BP pickups, which is the parent class and everything that inherits from it that we've done so far and will do in the future. So if we go to our BP drop-off area now, and we go and find its desired pickup, we can choose BP pickup blue, for example. Now we can go back to our drop-off area again, and we can, when we scan for objects, add some logic to make sure that it is an object that we want to give full bonus for or not. So what we can do is, let's make a few events. Custom event, and then we'll call this desired pickup found. And then we'll send in a reference in here. Let's see, we cast BP pickup, so that is nice. So we will use a BP pickup as a reference here, which means yet again that this one will come either as one of the children or the parent class in here. And then we'll make another custom event. We'll call this desired, no, let's call it not desired pickup found. And we'll do the same and add a BP pickup here. We'll call it pickup found as in parameter in both of these cases. Compile and save. So, what we want to do is, let us assume that we want to have this logic that happens here as the logic that happens when it's a desired pickup. So we will disconnect this. Let's see, we don't need to have that. We can, let's drag everything like so to to desired pickup here. So we will execute from here, in here, and say that the target there, time bonus, game state, change remaining time, destroy the actor. The actor is going to be the pickup that we got in here. So we will go in here, we will check what is the time bonus for this object. We will alter the game state by adding the time. We will then destroy the actor that we have found and we'll type out that we have destroyed an actor. And in the case that we have a not desired pickup, we can just choose, for example, to have the functionality that it will not scan and destroy it at all. So to have a debugging for this, we can print that not desired pickup was found. Okay. And yeah, we can remove that little node there. Okay, so now theoretically, if we go and put a blue box in here, it will go and say, never mind, we haven't finished actual logic yet. We're not calling to these functions, these events. What we want to do is, this pickup that we have here, we want to get its class. And then we want to compare this by typing equal signs twice, so equal class. And then we'll drag our desired pickup into the comparison here. So now we will check if this one is equal to the class that we rather want to have. Press B and left click to get a branch, and we'll have its result in there. So if it is the class we want, we go to the desired pickup. And if it is not, we go to the not desired pickup found event. But we do need to send both of these objects in here. So like so. Then I'll make another node here, like so. So we're sending in the reference to the object that we're currently processing. So now if we pick up a red one, and put it in the blue area, nothing should happen. It should just be typing out that it doesn't want it. If we put a blue one in there, we should be getting a timer increase. So let's try and see if that works. So the red one, we pick up the red one. This one should not be accepted in here. My mouse is acting up a little bit, sorry. So it's standing there and just saying, not desired pickup was found. Let's try and get a blue one. And then we'll put that one over here and look at our time. And our time is increased. So now we have, from our parent, created logic that cascades down to the children and allows them to work the same way as the parent. The only thing that differentiates them is a parameter that says what area it belongs to, which is typed out here, and which class it wants to take in, and that will affect its logic about whether it will accept it or not. So let us finish off by making another child class of the drop-off areas. We have one for the red one. And we called it area blue before, so area red now. And we might want to have some kind of other indicator as well as to... It's not very clear which one is which other than reading the name, of course, but that might be okay for now. So we'll put this one in here. We'll scale it up a bit. That's the opposite of scaling up. There we go. And now it says drop-off area only because we haven't actually set anything in this one. We want to go in and get the name, which is by default blank. Type in red. And the desired pickup is supposed to be pickup red. Compile, save, and now that one is done as well. So now we have already added some complexity to this. What are some other things that we could be doing? Well, on the topic of constantly iterating on code, we can, let's see if I can demonstrate it properly. If we let something spawn here, and then I want to pick up this blue cube here. That didn't work. I got the red one. Why is that? Well, currently we have, and we can demonstrate this, in our first person character when we try to pick something up. See here, we trace for a pickup and we pick up the object. So if we go into our trace for pickup, we can choose to have a draw debug persistent. What this does is for our trace here, it should be leaving us lines showing where this trace is actually happening. And that should properly display what our problem is. So if I go around here, you see I have a line that goes straight out from me, and this is the 3 meter range that we have calculated from earlier. But you can see that regardless of if I'm tilting my camera up or down, it's always going horizontally. The reason for this is that we're using our capsule component as our start location, and we're getting our capsule component's forward vector as the direction to shoot out. And our capsule component is always going to be in this rotation, because what we're moving around is not actually the capsule component. When we move our mouse, we're moving our camera. Well, when we're moving up and down, we're moving our camera. When we're moving left and right, our capsule component is rotating along with us. So what we need to do is do some adjustments to our trace to allow it to be more precise, so it actually hits wherever we're pointing with our mouse. Now that we have reasoned us to the point where we know what is actually happening, this should be fairly simple to fix, because what we're currently using is our capsule component. And what we instead want to do is use our first person camera. So we'll just replace all the references with our first person camera, compile, save, go back again, and then we'll click for interaction. And nothing might seem to happen, but something has happened. The problem is we just drew a line from our camera straight forward, which means we can't actually see it because it's like 1 pixel or even less from our vantage point right now, but if we sidestep, you can see it appear. So this is what's happening now. We're creating lines from where we stood with the camera as a point of reference, and then forward towards where our mouse is pointing, which is the crosshair. So if we wanted to take the red square before, we wouldn't be able to, but see, now we can pick it up and it's working. Yeah. Okay. That is all for part 3. I hope to see you in part 4. Keep on learning. Take care.